Hello everyone, welcome back to Leetcode number 198, House Robber. So the problem is the following. You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected and will automatically contact the police if two adjacent houses were broken into on the same night. Given a list of non-negative integers representing the amount of money of each house, determine the maximum amount of money you can rob tonight without alerting the police. So the solution here actually makes use of dynamic programming. My goal is to show the reasoning behind that solution. So first, let's look at an example. Let's say we have 4 houses with these prices. Actually solving this problem without doing anything else seems like a lot of work. Seems really hard. So we're going to simplify it a bit by thinking of smaller subproblems. For example, what if our robbing spree only ends at the first house? Well, then the maximum profit would be 1. What if we only rob the first 2 houses? Well, then our maximum profit would be 2. What if we only rob the first 3 houses? Well, then we would have to rob house 1, and then we would have to rob house 3, which is a maximum profit of 4. So if you think about this a little more carefully, we can generalize the logic we just stated into a DP solution. So in a DP solution, you have to make use of the answers for your prior subproblems. For this subproblem that we're currently at, we're standing at house 3. And when we're standing at house 3, we either can rob it or not rob it. If we rob house 3, that means that our maximum profit is the price of our current house added to the maximum profit for a robbing spree that ends at the house 2 positions before your current position, which is 1. Which means that you have 3 plus 1 equals 4. The other choice is if you choose not to rob your current house, which means the maximum profit is the maximum profit of the robbing spree that ends at the house 1 position before your current position, which is 2, which yields a maximum profit of 2. So you want to take the maximum of these 2 possibilities, which is what we did, right? We chose 4 because we want to maximize the profit, right? So in general, we can say that the following DP equation holds, which is that the maximum profit for the if house, here the if house just represents our current house. For this subproblem, that meant us standing at house 3. So the maximum profit for the if house is the maximum of 2 quantities. This first quantity represents what would happen if you robbed house I. So that would be the price of your current house, nums I, and the maximum profit of a robbing spree that ends at the house 2 positions before your current position. That is DP I minus 2. Now, if you don't rob house I, then the maximum profit becomes the maximum profit you get from a robbing spree that ends at the house 1 position before your current position. That's DP I minus 1. So it's kind of a mouthful to say what exactly these expressions mean, but I think mathematically it makes a lot of sense, right? We basically have 2 choices, and we take whatever choice gives us the most money at the end of the day. And we have these 2 choices solely based on the constraints of the problem, right? So this first choice where you choose to rob house I is only there because we can't rob adjacent houses. And the second choice is there if we choose basically not to rob our current house. So at the end of the day, in order to solve the original problem, all we have to do is take the last element in the DP table, which is the answer to the question, what is the maximum profit if you robbed all the houses in the original list. So hopefully that gives you a good conceptual overview of how we're going to handle this problem using dynamic programming. If not, I'll start writing the code and maybe that will clear some things up. So first, we should write our base cases. Let's see. Well, the first thing we have to consider is if the nums list is empty. So if length of nums is equal to 0, then we just simply return 0. Easy. If the length of nums is equal to 1, then we just return nums 0. If the length of nums is equal to 2, then we're going to return the max of nums 0, nums 1. So these are just the simple base cases that we consider for very simple problems. And they should all make fairly intuitive sense. For example, if the length of nums is 2, then you have no choice but to take the maximum of the only 2 houses you have to rob. Now, the interesting part happens when you have more than 2 houses to rob. In that case, we're going to do something like this. First, we're going to create a DP table and initialize it with all zeros. And then we're going to fill it in with our base cases. So dp0 should be equal to num0. Why is that? Because dp0 is saying, what if we only have 1 house to rob? Well, then that would mean we only need to rob that 1 house. So that's our base case. Now, what if we had 2 houses to rob? Well, then that would be max of nums 0, nums 1, right? Okay. Now that we have the base cases out of the way, we can start writing our DP equation. So that would look something like this. For I in range 2 to length of DP, we're going to do the following. We're going to say that DP of I is equal to max, literally copying this equation in line 27, nums I plus dp I minus 2, dp I minus 1. And then we're going to return dp of negative 1. So that's the code. It's very elegant, and hopefully you understand how it works. So let's just see if it actually works. Okay, that looks good. Alright, so as you can see, the code works, and hopefully the concepts make sense too. The time complexity here is big O of n, which means linear in the length of your input list. We also have a auxiliary space big O. Well, excuse me. We have a space complexity that is also big O of n, because we need this DP table, right? Okay, well, that is it for this video. If you liked it, please like, comment, and subscribe.